A particle moves along a number line not shown for t is greater than or equal to 0. Its position function s of t is shown in blue, so this is its position as a function of time. Its velocity function v of t is in red, that's velocity, and its acceleration function a of t is in green. All are graphed with respect to time t in seconds. With the graphs as an aid, answer the questions below. So that's what's going on here. So its position is a function of time. And actually, let me just draw their number line that they did not depict, just so we can really think about this. So let's say this is our number line. Let's say that this right over here is that's 0, that's 1, that is 2, this is -1. So we're defining going to the right as the positive direction. So what's happening here? So at time equals 0, right over here, time equals 0, s of 0 is 0. And then as time increases, our position increases all the way until time equals 1. At time equals 1, our position is 2. So at time equals 1, our position is 2. And then s of t starts decreasing. So we start, one way to think about it is, and you see we move up, we move to the right really fast, we get to 2, we stop at 2, and then we start moving to the left. So so time equals 0, the first second looks like this. We go zoom, slow down, and stop, and then we start moving the other way, and then we start drifting. Notice our position is decreasing, so our position is decreasing, but it's decreasing at ever slower rates. It's not clear if we'll ever get back to the origin. So that's what's going on here. And we see that no matter which graph we look at, our position function is definitely telling that story. Our velocity function, which is the derivative of the position function, is telling that story. Out the gate, we have a high positive velocity, but we decelerate quickly. And at 1 second, our velocity is 0. And then we start having a negative velocity, which means we're moving to the left. So fast rightward velocity, but we decelerate, fast rightward, decelerate quickly, stop at time equals 1 second, and then we start drifting to the left. And the acceleration also shows that same narrative. But anyway, let's actually answer the questions. The initial velocity of the particle is blank units per second. I encourage you to pause this video and answer that. Well, we just said the velocity, let's see, at time equals 0, we're at 8 units per second. So we'll just put 8 right over there. The particle is moving to the right when t is a part of, or when t is in the interval, and since they're doing this as a member of, they really want this kind of in the set notation. T is a member of the interval. Well, when are we moving to the right? We already went over that. We're moving to the right. There's a couple of ways to think about it. When our velocity is greater than, so we're moving to the right when v of t is greater than 0. When v of t is less than 0, we're moving to the left. When v of t is equal to 0, we're stationary. So when is v of t greater than 0? Well, it's between t being 0, velocity is definitely positive, all the way to t is 1, but not including t is 1. So I'll put a parenthesis there. So this is equivalent to saying, so t is a member of that interval, is equivalent to saying that 0 is less than or equal to t is less than 1. Once again, the first second, we're going at time 0, we're going fast, slow down, and then stop for an infinitesimal moment, and then we start drifting back. That happens at time equals 1. We start drifting back. The total distance traveled by the particle for t in the interval between 0 and 3 is blank units. So once again, I encourage you to pause the video and try to answer that. The total distance. So this is interesting. Don't get distance confused with displacement. If I were to move 3 to the right, and then I were to move back 1 to the left, the total distance I've traveled is 4. The distance I traveled is 4, while the displacement would be a positive, and we can put a -1 there. We moved 1 to the left. So 3 to the right, 1 to the left, while our displacement would be a net of +2. Our displacement would be a +2. So they're asking, what's the total distance traveled? So between time 0 and time 1, we have moved 2 to the right. We've moved 2 to the right. We've moved 2 to the right. And then between time 1 and time 3, we move back, or to the left, we move half. So to the left, we move half. So what's our total distance? It's going to be 2 to the right plus half to the left, which is going to be 2.5 units. 2 to the right plus half to the left, 2.5 units. And we're done.